One by one, we will try to review important fundamental concepts of radiation. The first concept is radiation intensity. Now, when we say that radiation energy is emitted by every matter, on what factor does this energy depend on? We saw that radiation energy is dependent on temperature, but the radiation is also not uniform in space or direction. There is also distribution of this energy along direction. A parameter known as radiation intensity is defined, which describes the magnitude of radiation emitted in a specified direction in space. This radiation intensity I is used to describe how the emitted radiation varies with the zenith and azimuthal angles. Radiation intensity is defined as the rate at which radiation energy Deg is emitted in the theta and phi direction per unit area normal to this direction and per unit solid angle about this direction. The formula for that is as shown here. The concept means the intensity by which radiation is emitted varies with space. To define its distribution along space, we have come up with a parameter which varies with the three-dimensional solid angle. So as you can see, the radiation intensity I is a function of theta and phi, which are coordinates of the solid angle or the angular discretization of space. So how they are measured? This is phi, this is theta. This denotes the three-dimensional location or angular location of this particular radiation emission. So if we take example of a slice of a pizza of plane angle alpha, this is the plane angle alpha. Radiation will vary along the azimuthal theta and phi directions. The solid angle slice of watermelon of solid angle is shown here, and this is the surface area, and this is the solid angle, and the radiation intensity will vary along the solid angle as the solid angle changes, location changes in three-dimensional space. So radiation intensity is a function of direction and space. Along with radiation being emitted, there is also radiation falling on a surface or matter. In reality, there is always give and take of radiation energy, so we also have to define intensity of radiation, incident radiation, in the similar way as we define intensity of emitted radiation. The intensity of incident radiation is defined as the rate at which radiation energy Dg is emitted from the theta phi direction per unit area of the receiving surface normal to this direction and per unit area solid angle about this direction. Formula or equation for that is shown. It contains the intensity of incident radiation summed up over the entire sphere, as it is a function of solid angle and space. Next important concept is radiosity. Radiosity is the rate at which radiation energy leaves a unit area of a surface in all directions. The formula for that is as shown. So if we sum up the interaction of a surface in terms of radiation, we have irradiation, which means radiation falling on the surface in this direction. Then the reflected radiation goes like this. This is the reflected radiation. And we have emissive power, which is the emitted radiation by the surface. So these two, that is reflected radiation along with the emitted radiation, form the radiosity parameter. Till now we have seen that radiation energy is a function of temperature, space, direction, and we also saw intensity of radiation leaving an incident on a matter surface or surface of a matter. Let us now see another concept which defines the variation of radiation energy with wavelength. We know that all types of radiations are defined in terms of wavelength. Different types of radiation have different wavelength. So spectral intensity is defined as the rate at which thermal radiation is no exception to this. So it also has wavelength defined, and the amount of radiation also varies with wavelength. Spectral is the term used to define at a given wavelength. So spectral intensity is defined as the rate at which radiation energy Deg is emitted at the wavelength in the theta and phi direction per unit area normal to this direction and per unit solid angle about this direction. So now we have even narrowed down the definition of intensity.